Hello everyone. In the last video, we have seen the singular integral equation and we have also found out the solution of one singular integral equation. Its name was Abel singular integral equation. Okay, it was Abel's integral equation. So, what was the equation looking like? The equation was of the form f of x equal to integral from 0 to x y of t dt divided by x minus t raised to alpha, and this alpha will belong to this interval. Okay, so alpha belonging to this open 0 1. Okay, then problems can be framed for this particular Abel integral equation by specifying what this f of x is. Like for example, I can take f of x to be equal to x square, or maybe cos of x into x square. Okay, so and by giving the value of alpha, like 1 by 3 or maybe 3 by 4 such that alpha is between open interval 0 and 1. Okay, so these are the types of problems which we can frame by using the Abel integral equation, and this equation is called as the Abel singular integral equation. Now in this video we will see the a similar type of equation, but the change will be like uh, suppose you observe this term here, okay, denominator. Now let us suppose take some function h of s to be equal to s. Okay, then you can clearly see that in this equation I can write its denominator as, this will be y of t, and denominator I can write it as by using this function h of s. So, okay, suppose I want to write the denominator. What I will have to write? I will have to write it as h of x minus h of t. Okay, so what this denominator will look like? It will be nothing but this pi of t divided by h of x will be what? H of x will be equal to x. What will be h of t? H of t will be t. Okay, and of course that raised to alpha, whatever it is. So this raised to alpha. Okay, so you can see that in the denominator it is the same function which is there in the first place and even in the second place. Okay, so now we will study a general form of Abel singular integral equation. Okay, and that general form will be given in terms of some function, like for example here I have shown you all h of x, h of s. Okay, so in general, if suppose here we have some function h of x minus h of t, then how to find out the solution of this particular integral equation, that is what we will see. Okay, but there will be some additional conditions. The conditions will be like this h of x cannot be any random function. Okay, it will have to satisfy certain conditions, like it should be strictly monotonically increasing and differentiable function in the interval of integration. Okay, or you can say in the range of integration. What is the range of integration? In this case, for this particular problem equation, what is the range of integration? How t is varying? T is varying from 0 to x. Okay, so in the range of integration it should be, we will be considering the range from a to b. Okay, and then in that range that function h of x should be monotonically increasing and differentiable. Okay, and there is one additional condition, but these are some of the conditions which this h of x function will have to satisfy. Okay, So general form of Abel singular integral equation it is given by f of x equal to integral from a to x, okay, y of t dt divided by some function h of x minus that same function but at t. Okay, so h of x minus h of t raised to alpha, and this alpha will vary between 0 and 1. Okay, so we'll call this equation as equation star, where now we will be giving the conditions what h of x has to satisfy, where h of t, you can say h of x or h of t, whatever it is. So basically the function h. Okay, so h of t is strictly monotonically increasing and differentiable function in a comma b. Okay, so this x point whatever is taken, that is somewhere between this ab, okay, open interval ab, and h dash of t is not equal to 0 in ab. Okay, so this is the general form of Abel integral equation, wherein there is a function h which is introduced along with some of the conditions. Okay, so our aim is to solve or to find the solution of this particular integral equation. Okay, so what we want to find? We want to find out a formula for finding y of t. Okay, if you see in the previous video also, while solving the Abel singular integral equation, we at the end we have got a nice formula how to for how to find the y of t. Okay, so to solve above equation star, we consider the integral, we consider the integral limits going from a to x, h dash of u into f of u du divided by h of x minus h of u raised to 1 minus alpha. Okay, so if you remember in the previous video also, while solving the or while finding the solution of Abel integral equation, we have multiplied the equation by some term. Okay, and then integrated it. We have introduced a new variable u. Okay, a similar type of steps we are going to follow in this case also, and then we did the interchange of the variable of integration, so the range of integration, and up. So the similar steps we will be following here also. So to solve the above equation, let us consider this particular integral. Okay. Now what we will do is, in this integral, you can see this f of u. Okay. We already know what is f of x, because f of x is equation star. Okay. So what we will do is, we will substitute this particular f of x in place of f of u, and then we will try to separate out y of t. Okay. So substitute f of u from equation star. So what we will get? Uh, so we will get integral from a to x h dash of u divided by h of x minus h of u raised to 1 minus alpha, and instead of f of u I will substitute this. Okay, so this is f of x. So what will be f of u? Wherever there is x, we will have to put u. So what we will get? Integral from a to u y of t dt h of u minus h of t raised to alpha du. Okay, so we will get this integral from a to u, then it will be y of t dt divided by h of u minus h of t this full thing raised to 1 this raised to alpha, and here it should be du. Sorry, no, not du, it should be dt only, and then outside it should be du. Okay, so this is dt. Okay, and then this is du. So instead of f of u, I have written this term, but already we have this. Now you can clearly see here what are these limits for which variable? They are for the variable u. So u is varying from a to x. So we'll write here u is varying from a to x, and these integration limits are for which variable? They are for variable t. So t is varying from a to u. T is varying from a to u. Okay, and now we will interchange the region of sorry, not the region of integration. By interchanging the limits, we will get. So let us look at the diagram and do that. So we'll have to take the two x's. What should be the two x's? Whatever are the variable of integration. So let me take this as t and this as u. Okay, and what will be this line? I always draw this line, that is because at some place there is u becoming equal to t. Okay, so u equal to t. Okay, now u is varying from a to x. So this is u vertical line. It is varying from a to x. So we will have to draw a somewhere. So let us suppose say this is a. Then if I extend this line, it will come here, and this point will be nothing but a comma a, and u is varying from a to x. So suppose that x is somewhere here. Okay, so this line, it will be u equal to x, and this line is u equal to a. Okay,
So u is varying 3.
it is varying from a to x, and t is varying from a to u. So t, where will be a? A will be here. Okay, so this is a equal to t line. This line is a equal to t. Okay, so t will vary from a to u. So it will start varying from here to till u. That means this line. Okay, so t will vary from here to here. So what is the common region of integration? It comes out to be this triangle. Okay, the region comes out to be this triangle. And now we will change the
limits. So now t will vary from, you can consider initially u was varying from a to x. Okay, so now so t will vary from a to x. So what we will get? So t is varying from a to x, means this region somewhere here. Okay, so it will vary from here to here, and then u will vary from t to x.
Okay, so we have changed, but again you see the region of integration is the triangle only. Okay, because u is varying from t to x. So this u equal to t is where? This line. So it will vary from here, this line, till x. That means
this. Okay, so it is varying in this region.
t is varying in this region.
So again the common region of integration is nothing but this triangle, the same one. Okay, so with this limits, now let me write the integral.
So what it will be? Outside I will have to take this dt outside. So this will be dt. So these are the limits of t. T is varying from a to t equal to x. Okay. So this will be y of t. There it is dt. And inside we will get whatever is with u will remain there. Okay. So this will be integral from u will x. Okay, and here it is h dash of u du divided by h of x minus h of u, this thing raised to 1 minus alpha into h of u minus h of t raised to alpha. Okay. So this full thing in the bracket, this one in one bracket, okay, and outside it is dt. So let us call this as some integral I, and we will evaluate what is this I, like the same way how we evaluated it for the Abel integral equation. Okay, so now we will consider I. So
Consider I equal to integral from u is going from
t to x h dash of u du divided by h of x minus h of u raised to 1 minus alpha, and the second bracket is h of u minus h of t raised to alpha in this du. Okay, so substitute. So let S be equal to h of x minus h of u divided by h of x minus h of t. Okay, so we want to do this substitution in this integral. So whenever you want to substitute for the variable of integration, remember that you have to change the three things. What are those? First of all,
the limits of integration will change. Then wherever there is variable u
vanish and everything should become in terms of s. Okay, that t and x can remain
because they are not the variable of integration for I. Okay, I am talking about this particular integral. Only for this integral, the variable of integration, it is u.
I am substituting for u. So in
the next integral, whatever I get, u should vanish completely. Okay, so I will have to calculate what is h of u. So let us, because here we will have to substitute that now. So we will calculate what is h of u first, then we will substitute for this du as well and change the limits. Okay,
so what will be h of u? So this will be s into h of x minus h of t equal to h of x minus h of u. So this implies h of u is equal to h of x minus s into h of x minus h of t. Okay, then h dash of u du is equal to this 0 minus h of x minus h of t into ds. Okay, and when u is equal to t, s is equal to what? So when u is equal to t, what will happen to s? See here in equation 3. When u is equal to t, so s will be equal to 1. And when u is equal to x, s will be equal to 0. So we will have to substitute all these things in I. So what we will get? So I will be equal to integral
from 1 to 0.
This will be minus h of x minus h of x minus h of t into ds divided by what will this become? H of x minus h of u is given by this particular expression. So it will be minus h of x minus
s into h of x minus h of t.
So that will be s into h of x minus h of t raised to 1 minus alpha. So here we will get s raised to 1 minus alpha into h of x minus h of t raised to 1 minus alpha. And what will this term become? This will be h of u. So h of x minus s into h of x minus h of t. Okay, this is h of u. So I am substituting for h of u minus h of t. So what will happen to this? This will be h of x minus s into h of x plus s into h of t minus h of t. Okay. So if I take h of x common out, or s, yes. So I will get, if I take h of x common, what I will get? H of x is 1 minus s and minus h of t. If I take common from second term, what we will get? 1 minus s. Now again take 1 minus s common. So what we will get? 1 minus s into h of x minus h of t. Okay. So here we will get h of x minus h of t raised to alpha, and that is 1 minus s raised to alpha. So this is the integral. Now you can see here this term and this term and this term.
All together they will cancel.
So this is minus alpha and this is plus alpha. So that will get cancelled and 1 will remain, that will get cancelled with the numerator. And because of this negative sign, I can interchange the limits and write it from 0 to 1. So what we will get? ds divided by s raised to 1 minus alpha, 1 minus s raised to alpha. Okay, which is equal to integral from 0 to 1 s raised to alpha minus 1, 1 minus s raised to alpha. Again the same manipulation that we have done earlier. I will subtract 1 and add 1. Okay. So after this, what we will get? I'm not getting the 1 minus alpha there. So okay, yeah, this should be minus alpha, right? This should be minus alpha when I take it in the numerator. So this is minus alpha. Okay. Now you can see this number. This is nothing but what? 1 minus alpha minus 1. Okay. So it is 1 minus alpha minus 1.
So this is nothing but the beta of alpha comma 1 minus alpha, and which is nothing but sine of this. I will not repeat it again because we have already used this identity in the previous lecture. Okay, so this comes out to be equal to sine alpha pi by alpha.
I is nothing but this quantity. Okay. So now we will substitute this I here. Okay, and we have already y of t, and on the other side what we have this. Okay, we have this quantity, this double star. Okay, we started with this double star, we took it to be equal to integral, that same thing, but f of u is equal to star. So we had substituted f of u in this equation. Okay, so now this equation becomes equal to, so I will write it here, integral from therefore we have integral from a to x h dash of u f of u du divided by h of x minus h of u 1 minus alpha equal to integral t varying from a to x y of t uh,
we are substituting for I, right? So yes, I think I have written the
integral it should be the other way, right? Here, because then that alpha is not becoming proper here. Yes, this beta alpha comma 1 minus alpha is this. What is that? Pi divided by sine of alpha pi. Okay. Yes, I made a mistake here. Yes. And you see that some of you may think like whether this quantity will be defined because there is sine alpha pi no, and alpha is varying. Alpha takes different values. But you see that alpha is taking the values only between 0 and 1. And now you can see in this region, so from 0 to pi, you can see the graph of sine. So what happens to this angle in the region 0 to pi? Okay, so that will ensure that this quantity is well defined always in this particular region. Okay, so that's it. So we will substitute that I, and then what we will get here. So this should be equal to pi divided by sine of alpha pi into dt. Okay, now we will keep this. This is a constant term, so I can very well shift it on the other side of the integral. So now I will get
from integral from a to x y of t dt equal to, take this on the other side, sine of alpha pi by pi
integral from a to x h dash of u f of u du divided by
h of x
minus h of u whole thing raised to 1 minus alpha. Okay, we want to find out what is y of t. So what we will do? We will differentiate with respect. Okay, because you see here the limit is from a to x. So whatever is this will be a function of x. So
we will have to differentiate it with respect to x. It will be
integral from a to x y of t dt equal to sine of alpha pi by pi d by dx of integral from a to x, whatever is this quantity. Okay, I will not write it again. So here what we will get? We will have to use the Leibniz rule. So in the LHS what will happen? We will get once this d by d it comes inside as a partial derivative. So that thing will become 0. Then the second term will be y of x into derivative of x with respect to x, that is 1, minus y at a into differentiating a with respect to x. A is a constant, so that differentiating a with respect to x will become 0. So the third term will vanish. Okay, we will get only this y of x to be equal to sine of alpha pi by phi. Here it will be d by dx of integral from a to x, then whatever is there inside. Okay. Now again, what I will do is I will change this x and I will write it in terms of y of t. Okay. So wherever there is x, I will put t. So what will happen? Here t will come. Here this will become t and this will become t. Okay. So let me write it properly. So that will be y of t will be equal to sine of alpha pi integral from a to t. Okay, here d by dt. Integral from a to t h dash of u f of u du divided by h of t minus h of u raised to 1 minus alpha. Okay. D by dt of this full quantity in the green bracket. Okay, so y of t is equal to this, and this is the solution of general general Abel equation. Okay, so I will uh, solve one problem completely and share it in the PDF, and I will also give you all some exercise problems which you can try based on the singular Abel integral equation as well as on the general form of integral equation. Okay. So here also the same thing will happen. When we frame the problem, whatever is f of u will be specified, as well as what the function h of x is, that thing will also be specified. It can be cos of x, okay, or maybe x square, or maybe sine of x. But the function has to be such that it is satisfying those three conditions. What were the conditions? They were, it should be strictly, monotonically strictly increasing, and h dash of t should not be equal to 0 in the region of integration, as well as it should be a differentiable function. Okay. Now this we have seen where the integration is from a to x. Okay. Now the integral equation can be also of the form this. Okay, that is f of x can be equal to integral from x to b. Okay, so because we are integrating it on the interval a to b, right? So what would be the next part? It can be x to b. So if it is this equation, that is y of t dt divided by h of x, so by h of t, the minus h of x raised to alpha. Okay, so if it is from x to b, you can be asked to evaluate this type of integral. Okay, wherein see here there was h of x and h of t. Here the order is changed. It is from h of t to h of x. H of t is the first one, and then it is h of x. Okay, so if it is this form of equation, then how do you find out the solution? That I leave it to you all to try. Okay, same steps will have to be followed, only the substitution will change. Okay, here whatever substitution we have done for s, that substitution will have to be change. So you can observe this properly, and then you will be able to figure it out. Okay. And some notes regarding this I will share in the PDF. We'll stop here.